Hey guys, today we're going to be going over the Unit 2 review, just to help better understand the entire unit prior to taking your test on Friday. Your test on Friday is going to be one of your first grades on the second 9 weeks. That way you're able to retake it the week after. So again, this Unit 2 test will not be going on the first 9 weeks, but the second 9 weeks. The beginning of your test will be the atomic history, or the atomic theory history. That's going to be all the people, what they did, and their models. To begin with the Unit 2 review, it says to make sure you study the history of the atomic theory review on Canvas. That had a list of all the people, what they did, and their models in great detail. The next question asks about Dalton's postulates and which were considered to be disproven. His postulates were that all elements are composed of atoms, which are indivisible and indestructible particles. We now know that that's disproven. We know that because you can break atoms down further into subatomic particles. So atoms are divisible. Atoms of the same element are exactly alike. We know that's been disproven because of something called isotopes. You can have two atoms of the same element, but they could have different mass numbers because their neutron value is different. Atoms of different atoms are different, that is true. And compounds are formed by the joining of two or more elements, and that is also true. Number 3 states, what were Rutherford's two main discoveries of the atom? We know that the atom, one of his big discoveries was that the atom was mostly empty space, which is our electron cloud. That the atom has a nucleus that's positively charged, and of course his other main discovery would be the proton. The gold foil experiment was Rutherford's experiment when he fired positively charged particles at a very thin piece of gold foil, expecting the majority of the particles to bounce back, because at the time they thought atoms were, it was the plum pudding model, because that was Thomson's model, and they believed that the entire pudding part, so the entire atom, was positively charged, which would mean really that that whole sheet, the majority of it at least, should be positively charged with, negative electrons scattering around it. What ended up happening is that the majority of them passed through or bounced off, and when they bounced off, they were actually hitting the nucleus, and the majority of them passing through, they were going right through the electron cloud. The cathode ray tube experiment was Thomson's experiment, where he put in neutral gas and ran an electrical current through it, passing through it, and it helped him discover the electron because he noticed negativity within a neutral gas, helping him understand that the atom actually is smaller than just the atom itself, and that was this first subatomic particle discovered, was the electron, by the cathode ray experiment. Who used it, and what did they discover about the atom? We know that Thomson used the cathode ray tube experiment, and it helped us understand that there were subatomic particles within the atom, or things smaller than the atom itself, and that the atom was divisible. At the time, Thomson called electrons corpuscles, but now it was renamed, or it has been renamed, to electron. The law of conservation of mass states that it cannot be created or destroyed. So it's always being transferred, but never created nor destroyed. Question 8 asks, what did Bohr believe about the movement of electrons around the nucleus of an atom? Bohr believed that electrons orbited the nucleus like planets orbit the sun. We now know that that's not true, that they actually have orbitals, or regions or locations that they're most likely going to be at, and different energy levels that they're most likely going to be at, but they don't actually orbit in these perfect circles around the nucleus. Who discovered the neutral subatomic particle, and what was it named? James Chadwick, which this was the last subatomic particle discovered, and it was discovered by James Chadwick, and it was the neutron. These are the different models of the atom. We know that the original model really was just a circle. It's pretty simple. And it wasn't until Thomson's plum pudding model did we have some subatomic particles in there. The pudding itself, so the orange part here, was positively charged, and then the electrons were scattered around it. That was for Thomson's plum pudding. Here are more additional models as they progressed. Rutherford's model, you can see the big change here is now there's a nucleus. There's something in the center which is now positive, versus before where all of the filled in pudding here was positive. Now it's just in the center, and the electrons are just kind of scattered without any kind of organization. Bohr, the planetary model, gave the electrons organization and energy levels, but the flaw with Bohr's model is that they circled the nucleus, which we now know is not true. They're more random than that. Here, which is the quantum wave model or cloud model, you have orbitals or regions or locations that electrons are going to be located. These regions or locations still have energy levels, which like the 1s, 2s, things that you were learning when you were doing the electron configurations. But we know that within that region, they're kind of moving more scattered or at random. They're not circling the nucleus. So they kind of stay within that region normally. Next, you need to understand the differences between each model, what's changed and why. You want to remember that at the beginning the model was just a circle. Then with Dalton it continued to be a circle. They considered it looking like a billiard ball. Then with Thomson it was the first time that we had a subatomic particle. So then at that point we had the plum pudding model, where you had the positive pudding with electrons scattered throughout. Rutherford gave us a nucleus, positive nucleus, with electrons scattered throughout, but it wasn't pudding anymore that was positive, it was just the nucleus and it was small in the center. Bohr put the electrons on rings or orbits, and the electrons would then go on those rings and circle the nucleus. After Bohr, we know the wave mechanical model, which then put them in orbitals, or regions or locations that the electrons are most likely going to be found. So that's just kind of how the atom has changed, the models of the atom have changed. So just make sure you look through that section. Of course, atomic structure is going to be a big part of this test as well, because we discussed a lot of atomic structure questions. Make sure you understand the three subatomic particles, your proton, neutron, and electron, their location, charge, mass, and purpose. Our proton is inside the nucleus, making it a nucleon. It's a +1 charge. It has 1 AMU. And the proton also can help us identify the atom because it's the same as the atomic number. Your neutron is in the nucleus, also a nucleon. It has a neutral charge, that's why you see a 0 there, 1 AMU, and the neutron's purpose is a buffer between the protons. The electron is located outside of the nucleus in orbitals, has a -1 charge, 0 AMU because the mass is too small, so we don't consider it a part of the mass. And electron's purpose is for bonding. You need to understand atomic number and what it's equal to. The atomic number helps us identify the atom, and how we also organize the periodic tables by increasing atomic number. And the atomic number is equal to the number of protons an atom has. Mass, or the mass number, and what is it equal to? The mass is the mass of an atom, and it's equal to protons plus neutrons. What is a nucleon? What particles belong to this group? A nucleon is any subatomic particle that is located in the nucleus, and those two particles are your protons and neutrons. Isotopes and ions was the next two PowerPoints we went over. You need to know what an isotope is and be able to understand more about it, like hyphen notation, your nuclear notations, those were all considered a part of the notes. An isotope is when you have the same atom with different numbers, mass numbers, and that's because the number of neutrons change. It says how does its mass number relate to that of a normal atom of the same element? It says that the mass number is either larger or smaller because it has more or less neutrons. And we learned that the number on the periodic table is the average atomic mass of all of the naturally occurring isotopes of that particular element and their percent abundances, which just means how frequent we find that particular element in nature. Ions, you want to make sure you can solve for a charge and you understand the definition of an ion. Ion is when you have an atom that has gained or lost electrons, giving it a charge overall. It says, how is the charge of an atom found? protons minus electrons, or P minus E. What is the charge of an atom with 8 protons, 8 neutrons, and 8 electrons? It would be neutral because the protons and electrons balance out. What is the charge of an atom with 35 protons and 36 electrons? And that charge would be -1. P minus E would give us a -1 charge overall, and that's because you have one more electron than you do proton. What is the charge of an atom with 26 protons, 29 neutrons, and 23 electrons? P minus E would give us a +3 charge. Do metals normally form anions or cations? They form cations, which are positively charged ions. So for number 4, that particular atom would form a cation. Do nonmetals usually form anions or cations? And it's anions. Number 3, with a -1 charge, would be considered an anion because it's a negative charge. Next, nuclear notation. So nuclear notation, you need to make sure you know like where everything goes. So you want to make sure you put your symbol in the middle. In the upper left-hand corner is going to be your mass number. In the lower left-hand corner is going to be your atomic number. And the upper right-hand corner is going to be your charge. Make sure you can calculate an average atomic mass problem. Average atomic mass, again, is all of your naturally occurring isotopes for that particular element and the percent abundances. So you have to take into account the percent abundance or how frequent you find them. The thing is when you put these problems in for the percent abundance, you have to take the percents out of percent. So like 5.07%. If you divide that by 100 to take it out of percent, it would be 0.0507. So just make sure you're taking your percents out of percent. That's important. Then you go through and multiply your mass times percent and add it to the next set until you've covered all of the isotopes for that particular element. Make sure that you can do your electron configuration and orbital diagrams using the Magdalen's rule or the diagonal chart. You want to make sure that you understand for every sublevel how many electrons can be held. S can hold 2, P can hold 6, D can hold 10, and F can hold 14. And then from there, just make sure that you know, for your orbital diagrams, how many lines to draw for SPDF. We know that S can only get 1 line, P gets 3, D gets 5, and F gets 7. Next, be able to write a noble gas configuration. Don't forget that you always need to pull the previous noble gas to your element, and that noble gas's configuration is taken out, and what's ever left behind is what you write out. The last part is the EM spectrum, which we didn't have a quiz over, so you want to make sure to really look over this information. You want to understand the EM spectrum and its order. You want to understand the relationship between wavelength, energy, and frequency. You need to know the speed of light, and you need to know how to calculate using the speed of light. Make sure you know this triangle so that you can solve for the different problems. So if you're solving for wavelength, the equation is speed of light over frequency. If you're solving for frequency or V, it's speed of light over wavelength. So just make sure you know that as well. And then the last few problems, you're just calculating, wavelength or frequency using the speed of light. Make sure that if you ever have a number that has an exponent like this, for example, like speed of light, and let's say you had to divide it by another number, anytime you have an exponent, you want to make sure to put that in parentheses. So you put parentheses, then divide, and then if this number down here had an exponent, that would also have parentheses as well. All right, that is your Unit 2 test review, so make sure you really look through this heavily, that you understand all the concepts. If you have any questions at all, please let me know.